Okay, I think we can start. Good afternoon, everyone. My name is Miroslav Milinovic. I will chair this afternoon session on the roaming. Actually, it looks like EduRoam session on new tools and technologies used around or with the EduRoam. So we actually have a real people using their virtual identities in order to achieve some work to be done. Our first speaker is Stefan Winter from Restena, Luxembourg, presented being from Luxembourg and still presenting a Swiss knife for EduRoam, actually showing us how we can do some additional things with the EduRoam tools, including providing it in the bus.
So,
you close this one
and then, stupid mouse.
No, you have the one down.
Oh.
Okay.
So,
Go to the.
yeah. Anybody know what full screen means in Spanish? There should be view. There?
F5.
F5.
This is C?
How many engineers do you need to have a full screen in Microsoft Tools?
I knew it was that, yeah. Okay, yeah. Thank you, Miro, for the introduction. My name is Stefan Winter from the Restena Foundation in Luxembourg. And yes, I'm going to talk today about RADSEC proxy. The original title was Swiss Army Knife for EduRoam, but in order to lure more of you into the presentation, I gave it the subtitle, Why Does EduRoam Work on the Buses? So I do have a few slides on how this was made to work. So we're going to start with what is this RADSEC proxy thing anyway? Is it something to eat, or can we do something different with it? Why did we do it? When did we do it? And what can it do? And in these feature lists, there is one thing about dynamic discovery, which I will talk a bit more extended about, because that's really a rather revolutionary thing to do. And to the end, I will show you what kind of impact we had on IETF standardization by having this piece of software. So, what is it in the first place? It's a piece of software. It was produced by Uninet within the JRF5 effort in Gen 2. And I have to say a big thank you to Stig Vennoos. As I've learned, the A is actually pronounced as an O. For doing really the bulk of the work. He has almost single-handedly written this piece of software. Unfortunately, he cannot be here today. Well, what does it do? This is a universal proxy for several radius transports. Some or most of you may know that we use the radius protocol quite excessively in EduRoam to authenticate users. What some of you might also know is that we are not entirely happy with all of the things radius does. It was specified more than a decade ago, and some of the things are really not quite adequate for today. So we thought about transporting radius payloads differently, and RADSEC proxy implements all these thoughts. The one that we had in mind first was called RADSEC in the beginning. That's why it's ended up called being RADSEC proxy. This is TLS encryption for radius and transporting the payload over TCP, instead of the traditional radius, which uses UDP and a very weak encryption with MD5 for its transport, which is indeed not adequate for today. Meanwhile, RADSEC proxy does even a bit more. The IETF has spun off some ideas about transporting radius over TCP without better encryption, for whatever reason, and also with using TLS encryption, but without TCP. That's about all the combinations you can make up from these two things. So RadSec proxy does all these things. You can send all your radio stuff over whatever protocol you like. You can also translate between all those. So if you have a device that speaks plain radios and you want to RadSec enable it, put RadSec proxy onto the device and just forward the radios requests as RadSec elsewhere. Now, with all these features, that's why I think it's justified to call it a Swiss Army knife, because, yeah, it really does all the things we ever wanted, transport-wise. So what can you do concretely with it? I've taken 3 bullet points here. First of all, if you have an access point which speaks radios, and it doesn't speak RadSec, you can enable this access point. We've done this quite excessively by using Linux-based access points, which you can easily hack. Put RadSec proxy onto them, and then you have a RadSec-enabled access point. One further layer up in the hierarchy, if you have an institution that uses radios to talk to Eduroam worldwide, and the radio server deployed doesn't do RadSec, you can also put RadSec proxy in front of the IDP or SP server, and from then on you can talk RadSec. And after a while, we even discovered that all the federation-level radio servers we have to broker requests within a country and to the international uplink, these are usually full-featured radio servers, but our requirements for those are somewhat lower because they just have to ship packets around and not actually authenticate people. And it turned out that RadSec proxy can take the full role of such a federation-level radio server quite easily. So yeah, it can be used pretty much on all the layers we have in the hierarchy. I will go a bit into detail about these specific things. This is a RadSec proxy in the .lu for Luxembourg domain. This is actually deployed like that. So we have one instance of our top-level server using RadSec proxy, having both a radios and a RadSec uplink to the European top-level radio server. This is the ETLR on the top. And then we have several institutions connected in Luxembourg. I just pictured that some may do radios, some may do RadSec, some may do a mixture of both. And RadSec proxy doesn't care. It just connects all of those institutions, no matter what transports they're using. This is the next use case about RadSec proxy at one institution. In the slide before, we had this pitiful institution, org1.lu, which was only talking radios. So if they wanted to change that, they can just install RadSec proxy on their radio server, assuming they have an operating system it's supported on. There is an experimental port to Windows, and all Unixes work as well. And from that moment on, the local radio server can just as well talk RadSec proxy to its uplink. And then comes the third use case, which I was talking about with access points. So you have an access point installed somewhere, and you can beef that up a bit and make it speak the RadSec protocol to your radio servers. Now the question is, why would you equip a single access point with RadSec? We primarily think about RadSec being useful in the long haul when we have international traffic in case a packet gets lost, so that TCP can continue your authentication. But there are indeed some use cases where you can make use of an access point that speaks RadSec. In this uplink, I just wrote up to some Eduroam RadSec server. One of the good things about RadSec, the protocol, is that it makes you independent of the traditional radios trust model, which is all the radio servers have to know the IP address of each other and have to share a secret before they exchange any data. This is, again, not quite contemporary. With RadSec, you can say, connect me to this domain name, to this host name, and I'll prove with a certificate that I'm entitled to do Eduroam. And so this, to some Eduroam RadSec server, really means if there is one Eduroam server on the planet RadSec enabled, you can talk to this one and authenticate your users via this path. And this is precisely what we have been doing in the buses. We had to use one more box because, well, buses typically don't have a fiber connection to somewhere. That would be a bit difficult, so we had to find out something wireless. So we put a UMTS uplink box. We have our access point with RadSec proxy, speaking the RadSec protocol to the conference venue here, to the authentication servers which are installed here. And by that, the access point can authenticate users, it can serve the users, and it just works. Now, when it comes to UMTS, I don't think I'm supposed to do any advertising. I just want to point out to the entirely coincidental fact that this UMTS box in my slide is orange. Anyway, thanks to the unnamed company who provided us with the connectivity. Okay, and this is how this actually looks like in one of the buses. So what you see right here in the center of the picture is the two antennas of an access point. This is a Linux-based OpenWRT firmware access point with RADSEC proxy on it. The gray cable goes to the 3G modem, which provides the UMTS uplink. And from there on, you are wirelessly connected to the rest of the world. And the blue cable is either going to Victoriano's laptop or my own one while we were debugging the thing. So, yeah, the next question then is, yeah, this is pretty nice, but there must be other products actually doing this RADSEC stuff. And that's true. So why did we put the effort of producing an entire new piece of software? Yeah, first of all, I have to say, we at Europe people are quite picky about our radius requirements. There are dozens of radius server vendors out there, but only a few actually handle our federated authentication with forwarding requests nicely. So I think the really good radius servers fit into one hand quite easily. It would be nice to have our own radius server implementation that we know is of high quality and which is tailored to our needs. Plus, if you want to try out anything connected to RADSEC, RADSEC started with being a proprietary protocol by the company who does the Radiator radio server. So if you wanted to use it, there was just one implementation, and that means you have to buy Radiator. That's also not quite what we imagined. Any large-scale rollout can't have as a target, everybody has to buy this one product from this one company. Another reason is that if you wanted to use Radiator and you had these fancy new ideas about yet another radius transport, hacking around with a product that's in heavy commercial use all over the planet is maybe not the place to start with your experiments. So we needed kind of a playground to get started with this in the first place. Finally, we were having these thoughts in JRA 5 about what to do about radius, how to replace it with something better. And we wanted to see our ideas actually happen in code so we could evaluate them. So we needed this up-to-date reference implementation. And that's why we got Uninet involved to do this excellent piece of software. Now, to give you a time scale about this, I was surprised myself a bit. This has been going on for longer than I thought. I discovered the first subversion commit of actual code of RADSEC proxy was in January 2007, with the latest version being released in March 2009. So this has been going on for almost 2 years now. Meanwhile, the product is really stable. You can download it, just use it. Apparently, we also have users outside of the annual community. There have been downloads from commercial providers. Usually, these people don't like talking about what they're doing, so the information here is a bit vague. But yeah, we are getting along a nice path. So regarding the details of the feature set of RADSEC proxy, yeah, first it can do radius, the just old normal radius. That's a pretty basic requirement we had. Then we had this RADSEC as the first thing to be implemented as a new thing. And over time, these two newcomers came in. There is radius over TCP. Even the specification in the IETF right now says that standalone use of this is not really recommended because, yes, it transports packets over TCP, so it's more reliable, but it's still using MD5 as an encryption for your attributes. And MD5 is known to be horribly broken meanwhile. Yeah, and the other idea then is have radius datagrams, encrypt them with a contemporary encryption, like X509 certificates in TLS, but not use TCP. Apparently, some people in the IETF fancy that. There is a use case for this, mostly because you don't have to do such excessive changes to radio servers to enable this one, because the TCP stack in itself is a bit of work if you were operating stateless on UDP first. But to be honest, we didn't see a lot going on in this area. There is one draft about it, but it has not been updated in quite a long time. Anyway, we implemented it to be able to play with it when it's due. And now for the one king feature in it, dynamic discovery. This is something we are still playing with, not really deploying in a large scale in eduroam, but it's something with quite a bit of promise. This one line here says, find your AAA server from an arbitrary metadata repository. This may sound a bit enigmatic, so I'm going to give an example on how this works and why you all know it already. Because it's absolutely nothing new. If you ever wrote or got an email, there was some kind of dynamic discovery involved, and a fairly simple one. So assume that this John here wants to write an email to someone at the domain bob.lu. Then the originating domain, the MTA, has the problem of finding out who is responsible for email in the domain bob.lu. And yeah, I guess everybody in this room knows the rather trivial answer that there is an MX record in DNS. So you ask DNS, who does the email thing for this domain? You get back an IP address, and then there you go. You send your mail, and that's it. So there is no kind of central or hierarchy as we know it in eduroam. You just ask some repository, get your answer, and deliver your stuff. If we take a look at radios to the contrary, I think it's fair to say that dynamics is the opposite of radios. The way eduroam works right now is that assume this user from DODE is in Luxembourg and wants to be authenticated. So the authentication server at home at do.de has to be asked if this user is acceptable. Right now, this means the access point asks his own radio server. That radio server says, I just know about bob.lu, no idea about do.de. So I'll just send it onward in my hierarchy. Maybe someone else knows about this domain. Then it ends up at the .lu server, also no luck. It's again sent up to the European root server. This European root knows about Germany and that there is a server for eduroam in Germany, which in turn knows DODE, and then the user can be authenticated. So if you think you find anything dynamic in here, please let me know. We have really failed to do so. So how does dynamic discovery for eduroam work now? Well, the principle is the very same. As an email, you have an eduroam service provider, which is the one with the actual access points deployed. And at some point, we would like to ask a DNS-like thing, who is responsible for eduroam authentications for this domain? And yeah, ideally, we would get back an IP address and be happy. The question is, do we want to use DNS or do we want to use RADSEC implementation? There was a DNS-based dynamic discovery foreseen. It was a bit better quality. In any case, we wanted to have a bit more flexibility. And RADSEC proxy makes it very easy for you to have this flexibility, so we can try out new stuff in the JRF3 of Gen 3 now. Actually, it has already been implemented that we asked the edugain metadata server, and the metadata server can store information about RADSEC, and you just get your answer back. And then you can avoid all this hierarchy thing that we have in eduroam. So you just find out, oh, this is the eduroam server for do.de. So I'm just going to ask there, could you authenticate this guy, please? He has some credentials. And the answer is, yes, I know him, let him on. Unfortunately, it's not quite that easy as an email. I assume most of you are happy to get email, unless it's spam. And there is no trust involved. You just get your email and deliver it, and that's it. For an authentication, this is something completely different, of course, because you just don't want to tell everybody that you know this user, and that this user authenticates with a certain set of credentials. So if just anyone in the world is going to ask an IDP, look, how about username Bob and password Bob? Is that by any chance correct? Then the answer from the IDP should really be, why would I tell you? Because otherwise you could fish out passwords. There has to be some kind of authority after these two servers have discovered each other. which means the eduroam service provider has to prove it is really an eduroam service provider, it has business, and it really wants to get an actual eduroam user to an eduroam network. Then it is allowed to have an authentication exchange with the IDP. And on the other hand, if the service provider has something in DNS or some other piece of metadata, what if this metadata is then at some point compromised and the user gets sent to a wrong server? This is also not something we like, so we want to have both of these entities authenticate each other before we actually allow communication to happen. Luckily, with RADSEC, there is an easy means of doing this. Since it's using TLS, and TLS can use certificates, we can just use X509 certificates, which have a special entitlement in the certificate identifying, yes, I am an eduroam identity provider, or yes, I am an eduroam service provider. Yeah, and once this is sorted out and the TLX exchange really verifies that there is an eduroam conversation going on, then the actual authentication can be exchanged. So there is no hierarchy involved anymore, but this is still a bit into the future. We are right now trying to figure out, do we want to use DNS? What exactly do we put into DNS? We are trying to standardize in the IETF how to put such information into DNS. Then we also have the edugrade metadata server. Is this something we want to pursue? This is still a topic of current research going on in JRF3. Yeah, now the impact of standardization. When I started to do the RADSEC thing in the IETF, we just had this vague idea to take the proprietary RADSEC protocol from the Radiator people, OSC, Open System Consultants, and have that somehow rubber stamped. Meanwhile, the IETF has picked up on those ideas a bit more thoroughly, and it's become a bit of a larger topic. So the TCP transport part was split out. There is TLS encryption either for TCP or for UDP. So we just want to have this TLS part agnostic of the actual transport beneath. And there is the still using UDP but TLS encryption DTLS transport. Finally, we also had this dynamic discovery in my original RADSEC draft to the IETF integrated. The IETF thought, well, let's first sort out the bits on the wire for TCP, UDP, and TLS. And your fancy thing with dynamic discovery should be a separate document. For a number of reasons, the top one being that, meanwhile, even the diameter people have identified that even though they did specify some dynamic discovery in diameter, it was just basically 2 lines in the specification, and it was by far not thorough enough to be actually used. So this is becoming more or less a joint document to be usable for radius and for diameter. So yeah, this software and these things we played with turned this one draft I was submitting to the IETF a bit more to a new transport landscape for radius. And I'm actually quite proud of that. Good, yeah, and that basically concludes my presentation. Thanks for your time, and either bash me or just have normal questions.
So thank you, Stefan, for doing that on time and being so elaborate on RADSEC development, showing that it can be used in buses. Any questions? We have time for, yeah.
Hi, Stefan. As you probably know, we're looking at RADSEC proxy in Australia at the moment, and the question that we had, which is the only sort of minor concern, was who will be sort of responsible for the ongoing support and development of RADSEC proxy, so that we can be assured that it's going to continue. Is it community-led, or is it going to be Uninet or someone else?
You have mic.
Yeah, okay. Thanks for that question. It stems probably from the fact that, well, Stig Berners isn't here today because he has changed jobs. So the original author isn't there anymore. There is ongoing support from Uninet. There is still the RADSEC proxy mailing list, and you can ask questions, and there are people from Uninet answering it. When it comes to new features being put into RADSEC proxy, this still isn't the process of being sorted out. So we definitely want to continue this. We have Gen 3, we have JWave 3, so we have the means to develop it. Finding an actual person who is fit in writing C code, well, that's a different topic, but it's not going to be abandoned. And furthermore, meanwhile, there is not just RADSEC proxy. There are more things coming up. There are RADSEC implementations. We have one ongoing implementation for free radios, which we hope, well, we hope it should be finished already, but we really hope you see the results sometime soon. And by that time, you have RADSEC support in a commodity radio server with excellent support. And actually, you have it in the radio server, because we think that's at least one of the two most popular and most useful radio servers. So it's not just RADSEC proxy anymore.
Oh, one more question. Somebody had.
Directly in DNS to make the dynamic resolution.
Yes, as I've said, we might be using DNS for the discovery, and actually SRV records are our top #1 candidate. Yeah, so it's not by no means abandoned. SRV records are specified in the current draft in the IETF. It's just that we are not really entirely sure yet, but SRV records is still on the table.
And one of my final question from me, because we are out of time, but in short, did the experiment with buses worked out, or you have an additional slide in here to show us?
I think you might be asking this because I have an additional slide, and you know that. Yeah, it's been working pretty good for most of the people. We had a few glitches to consider.
In a minute or so.
In a minute? Okay.
Don't go in details.
Okay. Bullet point 1, it didn't work for you on Sunday morning because it doesn't help if you have 7 buses equipped with it and they are sitting in the depot and other buses serve your line. So that was one pretty obvious reason why it didn't work. Then we had a rather practical and unfortunate thing that when you reboot the bus, which means you turn it off and have it in the depot, next morning you turn it on again, the UMTS modem took almost 2 minutes to get an actual internet connection. The access point was ready much before that. Tried to get online to the internet, had no DNS, no NTP, no TCP, and it gave up. So we had to introduce a restart delay so that the access point actually tries to get its connection up later. Then, yeah, we are talking about UMTS. For some people, mostly those using EAP-TLS, there were apparently some problems with reliability of the authentication process. I think it has to do with UMTS not exactly being a lossless fiber backbone and packets getting lost somewhere, but we are still investigating that. And the one reason I would like to say aloud to all the access point manufacturers in the world, they saved about ½ eurocent by not having a hardware clock on their devices, which means whenever the device boots, it thinks it's the 1st of January 1970. So it thinks that neither PKI nor certificates have been invented yet, and most certainly, the certificate on the box is not valid yet, which really was one of the more stupid reasons why it didn't work in the beginning. Okay.
Thank you again. I feel sorry that we have to, end at this moment. You'll probably learn why you have been all the time on the buses during the last 2 days. And I'd like to introduce another speaker, or the second speaker in the row. Let me find the mouse. Tomasz Wolnowicz from University of Torun. Tomasz, please. Who will talk about a little bit more about the identity management in the EDROM, or do we really want our users to be still anonymous? Huh?
Yes, so of course EDROM is in a large extent about managing of user identity. So this title could sound a bit strange, but actually, as it turns out, there are some problems with anonymity of users or pseudo-anonymity of users, and then they can pose certain problems for service providers. So this report is on the work that's in a way going forward towards problems that may appear in the future rather than for problems that exist right now. I think EduRoam is at this time working really in an excellent way, and we just want to make it better. So Stefan has already shown how EduRoam now works. This slide shows more or less the same thing, but more from a local site point of view. So we have 4 main players here. First is the user, depicted as this laptop. Then there is the network access station or access point, or maybe an access point controller. And then there is the service provider or the visited institution radio server. Then there is the EduRoam infrastructure, whatever it may be. It can be either the current hierarchical structure, or it may be direct connection over RADSEC, as Stefan has described. It doesn't matter for this picture. In the end, there is the IDP, the home institution of the user. So the important thing here is what we see on the top. The user authenticates, or at least may authenticate, by just providing a very general name, which essentially just has the realm in it. And in return, the IDP will return an access accept with more or less nothing in it, just saying, okay, this authentication went through correctly. So the visited institution, the service provider, doesn't really have a clue about the user, which has some advantages from the point of user's privacy, of course, but it also poses some difficulties, which I will mention later. So EduRoam authentication has, from the very beginning, has been designed in such a way that the users can remain, let's say, hidden from the institution they are visiting. However, if they misbehave, there are means of finding out who they are. I'm not going to go into these policy questions, but it is possible to, by correlating logs from the service provider and from the identity provider, to tell who the user was. However, this is a process that takes some time, and you could say that in the short term, the user stays anonymous from the point of view of the service provider of the visited institution. So what we suggest is a way of dealing with this problem by introducing something which is definitely not new, by simply adding an opaque persistent user handle, or something which is in the very idea, more or less exactly, the EduPerson targeted ID as seen as in other AA scenarios. So this is what I'm going to talk about. Just present a short case study, present a few cases where we think this thing may appear, and how it can be solved with adding this extra user identity. Then talk a little bit about privacy considerations, describe how exactly we want to solve this, and a few words about the implementation. So the first case is a timely reaction to network incidents. As I've said before, there are means in EduRoam for finding out who the guilty user is and reacting to it. But the procedures that need to be taken, first of all, need to be justified. It can't be just any question or any problem raised by the ESP. That the ESP needs to find out who the IDP is, what is the contact, and so on. Normally, there would be a whole structure of EduRoam engaged into it. And in most cases, this investigation would not be done by service administrators. It might have to go down to, well, police or law enforcement agencies. But let's just take a look how the system would work. Well, first of all, the SP would observe an incident, and it might do the first thing is just block this user by blocking the MAC address. But this user, if he really means to disbehave, can just change the MAC address and re-authenticate, and he will be online again. If he does nothing from this point, nothing wrong, then, well, this will be probably the last thing we've heard of the incident. But if he disbehaves again, then the SP administrator will need to do something about it. So he will probably trigger the whole eduroam system. In the meantime, he can just block the entire realm of this user, which means cutting off every user from the network. If this happens to be a Terena conference, it would be a little bit user unfriendly, yes. If the local administrator had a unique user handle, he could just block this user handle, and that would be it. What I've described applies to major network incidents, but there may be minor network incidents. There may be an overuse of local regulations. So if such a, let's say, minor case was brought down to the IDP administrator, then what the IDP can do, the only thing he can do, is to block the user from eduroam as a whole, which means cut off the user from every eduroam institution. This is a very harsh thing to do, and the local administrator may hesitate whether he actually wants to do this. So again, if the SP has a unique user handle, then this decision can be taken locally. We'll only block the user from this particular SP, and this will be all that the SP needs, and the user won't have any more problems outside of this particular institution. Now, there's another thing, which is maybe not an incident, but something that we are in eduroam are beginning to see. eduroam or any wireless, university wireless network is, of course, very useful for those users who just happen to live within the range of this network, yes, because they can just set up a long-term connection. As long as these users are the members of the institution which owns the network, this is more or less okay, probably. However, if they are using the guest access to another institution, then this other institution may not be entirely happy about that kind of use if the user just keeps a long-term connection and pushes huge amounts of data. Again, to realize that a thing like that is happening, you need to know that these bytes that are moved belong to the one user, that this user will not be changing the MAC address every time he connects, and therefore we are not able to observe that this is a single user. On the other hand, if such a thing is observed, we don't really have means to react to it. For instance, we could put on some QoS restrictions on such a user and so on. And finally, collecting guest user statistics. This is also fairly important from the point of the service. The service provider can count the number of MAC addresses, can count the number of authentications, but cannot really count the number of users if they use this anonymous identity. And the MAC addresses, well, first of all, they can be changed. Secondly, they can belong to many devices that this user is using. So if you want to have a number of users, then you really have no means right now. And this user handle would be something that you could use for it. Besides, there is something like radius accounting, which allows you to count the bytes that each user has shifted. And even for local usage, the correlation of these accounting messages to actual users is fairly tricky. With guest users, it's more or less impossible. So, of course, we propose that such an additional user handle should be introduced. And so let's think for a moment of whether it actually brings some privacy threats. So we have set up a number of conditions that such an identity should have. Well, first of all, it should only be supplied on demand. We are not sending such a handle just to anybody, but only to those SPs that are asking for it and have a valid case. Well, if they are asking for it, we assume they have a valid case to have it. Secondly, the true user identifier should be impossible to recover. So this user identifier quite often is a user email, for instance. We don't want to be that available to the SP. Even if all algorithms known used for creation this user handle are known, then it still should be impossible to get the actual user ID. And finally, those persistent user IDs supplied to different service providers should be different, so that it should not be possible to correlate data from various SPs and to have some user profiles. So I just quoted the edu-person targeted ID definition here to show that this is exactly what we need, and we just need a way of implementing it within eduroam. But before I say how we would like to suggest doing that, a quick discussion of why can't we use a MAC address, which is something that every user, let's say, gives to the service provider. This actually is something that could be interesting from the privacy point of view in itself, because really the user leaves a trail of his visiting various institutions by just providing the MAC address during authentication. In laptops, the user can usually change the MAC address if he knows how to do that. On various other devices like mobile phones with Wi-Fi and so on, this may not be so easy or even possible. But for the case that we are discussing here, the MAC address is really not useful at all, because first of all, it is controlled by the user. Even if the majority of users never change their MAC addresses, the whole thing that we are talking about here is about those users who want to misbehave, and those users usually know how to fix their MAC address. Even worse, changing the MAC address can make this particular connection look like a connection from another user. Again, the true eduroam infrastructure is able to distinguish between those, so there is no real threat. But from the, let's say, very initial point of view, this could look like one user is posing for another one. And there's no way we can insist that users keep their MAC addresses constant, as this would obviously violate their privacy, and besides, there would be no way we could make sure that they actually do that. And finally, the MAC address is, of course, the identifier of the device and not the user. So when this whole set of user cases came up, we thought that, okay, we need to have an attribute that could pass this user identifier. And for a moment, I guess some of us were close to actually thinking of a new radius attribute, but then a knowledgeable person pointed to us that this thing has been actually thought of before. And there is an RFC which defines so-called chargeable user identity. The very name of this attribute already shows what this attribute is meant for. It is the chargeable user identity, therefore it's meant for charging in situations where network access is charged. The service provider needs to have a handle to which it will assign a bill. In eduroam, we are not assigning any bills, but still having this unique user handle could be a very handy thing. The way that the chargeable user identity, or CUI, has been designed, or actually the main means, the main purpose of designing it was to use it in the access points and in radio servers, so that the access point, even when it sees just this outside or outer user identity, which is meaningless, will be able to assign the accounting session to an actual user handle. So that if an access point really has the CUI support built into it, it will get back the CUI user handle and will then make all accounting in the name of this particular handle that it gets, so it can easily set up various accounting sessions to various, let's say, users. Yes. However, up to date, we don't know of any implementation in access points, and there's also probably hardly any support in radio server, at least not a fully functional one. So how do you want to use chargeable user identity in eduroam? Well, first of all, since we really have no means of doing anything to the access points, we just want to disregard what's in them and build the entire implementation in the radio server. Of course, we want to safeguard users' privacy, so we want to have the CUI to have all those privacy conditions that have been described before. Now, about the implementation. We now have a fully functional implementation in free radios. Hopefully, this will going to be part of the actual standard free radios distribution in maybe not a very distant future. What we have done is, first of all, the pure chargeable user identity implementation, so just according to the RFC, and secondly, some eduroam extensions. What are these extensions? I will describe in a moment. Fortunately, there was no code modification needed, or actually one tiny code modification which Alan Deacock has done himself and made available to us. The entire CUI implementation is really done in the configuration language and configuration files of the free radio server. We have implemented the service provider and the IDP parts independently, and you can switch them on and off independently. In most cases, one radio server will probably run both IDP and SP, but in some cases, you actually may have two different servers, or you may act only as an SP or maybe only as an IDP. Therefore, it's no point in switching both of them if you don't need them. So the very basic approach is that on the service provider side, we need to set up a CUI request. The CUI request is just a chargeable user identity attribute added to the access request radius packet, and normally the value should be nil. That is, well, \0, yes? And if on the IDP side, we have built a system where when you see the chargeable user identity request, you then look up the actual username that this request corresponds to, and you build a hash and send it back as the CUI value. In eduroam, we add one extra condition. To the access request, we add one extra attribute as the NAS identifier, and the value of this attribute should be a handle or to the institution. This way, when we on the IDP side, we can take this identifier of the institution plus all other inputs for our algorithm and create that MD sum or any other hash of that sort, and be sure that it will be different for different institutions. There is a slight weakness in this, but for the time, I'm not going to mention it now. Well, if you spot it, we can maybe bring it up in questions. Once again, the same slide as we had before. I told you just to remind that the access points can only see the outer username, which is normally meaningless. Therefore, for accounting, it cannot do very much about assigning the accounting session to the user. So one extra thing that has been done was the support for accounting. So when on the service side, service provider side, when the access accept arrives, the server records this access accept, takes all additional data it has, and creates a temporary database record. And then when it receives an accounting request from the access point, it looks up in this temporary database the record that matches some parameters of this accounting record, puts all these together, and adds the corresponding chargeable user identity value to this access, to this accounting request. Therefore, this way the server does what the access point should be doing in the first place, yes? But since the access point don't do this, we have a way of actually doing the same thing in the server. These things are kept in this database. Whenever an accounting stop is accounted, we simply clean this record. If there is, if no accounting stop arrives, which may happen due to various reasons, this record will stay in the database, so the database needs to be cleaned up periodically. So this is how this authentication exchange now looks like. We send the access request, which contains two additional attributes, the CUI with a null value and the NAS identifier corresponding to this institution. And in return, we get an access accept with a CUI value of some meaningless number or string, which, however, will stay fixed for this user and for this SP. And just a very brief description of one other thing that we did. Having the radio server which supports CUI is fine, but you need a tool to test that it actually does what it's supposed to be doing. Of course, you can set up another radio server and test the thing between them, but you can, for many reasons, it is quite handy to have a lighter tool, and this is the EPOL test, which is part of the WPA supplicant. A very useful tool for debugging EAP connections, and we have expanded this. It is now supports adding additional attributes, and the standard distribution of WPA supplicant starting from version 6.7 supports that. You can take a look at the slides or the paper or the actual tool to see how you add those additional attributes and how you can test that your server really works. So just to summarize, we think that the current support is really fully functional. It can be introduced into Eduroam gradually without breaking up anything. By adding extra value to the service, and maybe in some cases being introduced only between institutions which have a problem at the current moment. We have this implementation. It's running in a production service, so we can say it's stable. Some future things maybe need to be implemented. And finally, the acknowledgements to various people who helped along the way. Thank you.
Thank you, Tomasz. We have a, okay, Father, you can ask a question. Klas Virha, Cisco, Eduroam Father. Okay.
First question, is there a price for spotting a weakness in the CUI calculation algorithm?
Well, no.
Okay, then my question, it depends on the NES identifier being unique. Otherwise,
Yes.
two different SPs will lead to the same CUI. Have you thought about ways of getting rid of that problem? I mean, since you store anyway, you might just just put some random number and associate that with the user or not.
Well, no, because the IDP doesn't know the originating SP, right?
Right.
So my guess is that in the current Eduroam structure, we could have the Eduroam proxies to simply check that they are not getting the same values from different SPs. So this is a policy more than a technical way of solving this. In the future, when we get to direct RADSEC connections, then we will actually know which SP the connections come from, so we maybe will be able to drop the NAS identifier altogether, because we will have the identifier coming in.
Thank you.
Okay, one more, and we have to mark. Just a second, wait for the mic. Here is the gentleman. Oh, yeah.
Do you have any research or figures on how many problems this would have solved for you over the last year, say, if it had been in place across your region?
No. Well, I am, the main reason that we have really come up with the question was that as the site administrator, observing those long-term links and from discussions with other institutions, I realized that as Eduroam gets more mature, more popular, then institutions may become unhappy about users from one institution overusing the network of the other. And this was my main initiative, let's say, for bringing this subject up. But the other things sort of come up as a natural consequence.
And you don't think the long-term usage problem is serious enough to refer through the existing Eduroam resolution policy?
No, or maybe I misunderstood your question.
Is there a reason why you couldn't contact the originating institution and say, could you locate this user that's abusing our...
But this is exactly the problem, that we don't really know which user is causing the overuse, because all we have is accumulated data from this particular institution, right? So having this user handle can, of course, well, we can fix this on site in our case, or we can contact the other institution telling this particular user, is this behaving, could you please do something about it? But without having this handle, we can't really tell whether this huge amount of data is accumulated from a number of users or from a single user, or maybe this user is hopping, changing every day, and so on.
If I may jump in and close it, I see two things here. One is reaction, or if you want, a blacklisting of a user, and the other is establishing identity. In my eyes, this tool actually helps you to have a more efficient blacklisting, local blacklisting tool. And you will still have to establish the identity if you really want somebody to react upon the user, I mean, do something nasty to him, like, you know, delete his identity and banish him from using internet at all. I'm joking. But I see a difference in this. I don't know if we agree on that, but we can probably continue afterwards because we are stealing time from our last speaker. Thomas, again, thank you. And I have to kind of repeat my... Our last speaker is Enrique de la Hoy, and I hope I pronounce it well. I have a problem with this family names, and he will try to bring the EduROM where it has never been before in the space of the universal SSO. So Enrique, please.
I don't know if I have put my microphone properly, and I hope it didn't interfere with my robot, but I'm going to, well, the thing is, my name is, well, my name is Enrique de la Hoz, and I'm going to present our work that is called an InfoCard-based proposal for unified single sign-on to EduROM. And then first, a little bit of background. As you all know, EduROM provides us with wireless connectivity in all educational institutions all along Europe, and not only Europe, also in the Asia Pacific area network. And the good thing about EduROM, we all experimented, is that just by using our home institution credentials, we just do magic. We can open our laptop and we are online, and we can connect to the network. And if we review some previous work, for example, the work that was developed under the DAME project, there is one question, that it is, what if we try to reuse the credentials that we have exposed to the EduROM network to provide other services other than only the network access? What would be the desired goal? The desired goal would be to achieve a real single sign-on. The thing would be to be able to open our laptop and not only getting network connectivity, but also enjoy any service that we are allowed to use from our institution. Our idea, our departing point, was to bring together the two main confederation efforts that we can find in Europe, that it is mainly EduROM and EduGame. Well, there are a lot of questions. Why? What? Where? Well, the thing is, it's quite easy. It's really easy to say. Once a user gets into EduROM, we have that user authenticated, and as long as she or he remains in EduROM, we know who he or she is. What's our first idea is to employ that information to avoid further user logins. We want the user not to introduce their credentials, mainly the user and the password, again, just to access, I don't know, any service that we want to federate. What is the main problem, or the first problem at least that we had to face? EduRoam is mainly a network service, is layer 2 or layer 3, and most of the services we are interested in are mainly in upper layers. Well, our solution, it's in the line of the project, it's provide the user, after EduRoam authentication, try to provide the user with some credentials when the user successfully access EduRoam. What is our second idea and one of the most differentiating point of our proposal is using information cards as the credential to authenticate users. What is information card? Well, the first thing to do about information card is something like a cool technology. A lot of people is talking about information card, but it's good to put some clarification. We have a quite complex definition, and it's a unique identifier from an identity provider that users can employ to visualize the digital relationship with the identity provider in user interfaces and request security tokens with claims from the identity provider. In a few words, there are a kind of virtual cards for accessing and for getting claims and for presenting attributes at different services. If we want to do real, an information card is just an XML document. It's a kind of artifact that can be used to get security tokens containing the value of a set of requested claims. One thing that is quite interesting about information card is token agnostic. The security tokens that we are going to be able to get could be anything, for example, OpenID or SAML. It fits quite well with the kind of application that we want to use that are claim-based application, attribute-based application, and it is built upon standard protocols like the web services protocols are. Well, we want to put both things together. We want to make them meet. So, well, it looks cool. It's magic, again. What does this have to do with EduRoam? What are you going to do? You can be thinking, well, what are you going to do to put both worlds together? Our proposal to join both worlds is to associate an information card with an EduRoam session. And, well, a typical use case could be a user opens his laptop, the user then connects to EduRoam, and on successful EduRoam connection, she will receive an information card. We are going to call that information card from now on an EduRoam information card. So once the user has inside his machine the information card, the user can browse services and can access services just employing the so-called EduRoam information card. As soon as the user leaves EduRoam, the information card will no longer be valid. So we keep the concept that I have explained previously, that there is a direct association between the information card and the EduRoam session. So you are not going to be able to get tokens saying who you are or saying things about you when you leave EduRoam. Well, that sounds great. Just log into EduRoam and you are done. I explained some of these things some months ago in Utrecht, and you put the point in, oh, okay, InfoCard is not a real single sign-on technology. If we dig into the information card protocol, this is something that I am not going to do today, you discover that you need to authenticate to get the security tokens. Well, we want to get rid of passwords, but if we are putting another password just to get information card tokens, we are not getting anything. We are not getting any success. Well, there are another possibilities to get rid of password. For example, using certificates, client certificates, to authenticate the information card-based retrieval of tokens, or using a self-issued information card. That is, the user can generate by his own a self-issued card and use that card to back the managed information card that in this case is the so-called EduROAM information card. This way, we could forget about password and we could just get the token and use things just by only logging to EduROAM and getting the EduROAM information card. What is our proposal? Well, we have some previous work, and we wanted to keep the work as simple as possible, but the few things that we have to do, we need to modify some parts of the radius dialog. We need to introduce additional information in the radius dialog, and we decided to use protected EAP, exactly the version O, version number 0, that is using EAP with Microsoft Chat, and it is some few modifications that the user needs to send the card ID of the self-issued card that he wants to use to back the EduROAM information card in his request, and also in the radius reply, he must include the EduROAM information card. How are we going to make these pieces of information travel in the network? We have defined a new TLB, a new message, that it is called the SMH. I will translate the acronym now. On the request, it will contain the self-issued card ID, and on successful login, on the reply from the radio server, it will contain a one-time time-limited URL to download the information card. Why SMH is not a strange acronym, it's just the name of the developer. He wasn't very confident on me saying his name, so he decided to put his own name in the TLB, and I find it funny, and we have kept it. It's the main developer of the project. And on the request, it will contain the self-issued card ID, and on successful login, it will contain a URL, as I have explained previously. Well, we have something like well, there are some problems. Well, we have a roaming woman. We do not want that kind of roaming woman. We have a normal woman with her laptop. He tried to access internet, tries to connect to EduROAM. Then he went to the radio server. Her request is redirected to the radio server. We are in the user authentication. Once the user is authenticated, the radio server will contact a service that will be in charge of issuing information cards, the information card that we have called EduROAM information card, containing the attributes or the references to the attributes for that user. We will be able to generate an information card for that user, and the simple SAML PHP that is acting as the info card generator server will send back a URL containing the specially crafted URL referencing the location of the EduROAM information card, and in the success message sent by the radio server to the user, we will be able to find the reference, the URL for the information card. Once the user gets that information, he will retrieve the information card from the simple SAML PHP. There are some security measures here. It is a one-time. It only can be used once, and also it's time limited, just to avoid any attack from any man in the middle. And once the women and the user, in this case, has the information card, he can access, well, this X should not be here. It's a problem with the PowerPoint. He accesses any website, any service. He can get access to any federated service. Oh. And the thing is, as soon as the user leaves EduROM, that's when the red cross appears there. The information card is no longer valid. Okay? We have been able to build a prototype. It seems like a kind of magic and everything, but it has a lot of work behind. And the main things that we have done, they are detailed here. We have been able to achieve, it is necessary to have some relationship between the supplicant and the identity selector, and that's needed for our proposal. The supplicant must be able to retrieve information about which self-issued card the user wants to employ, and the identity selector must be able to import the card after successful login, after successful retrieval of the card from the simple SAML PHP info card generation server. We are using, in our prototype, in our model, FreeRadius as the radius server. We have developed a Perl module that is in charge of most of the work, that makes quite easy to deploy the system. And we have made really minor modification to existing FreeRadius code. We have also developed a module for simple SAML PHP that includes all the information card related functionality, the STS functionality for information cards, the card generation functionality, and we have also made a small application that it is in charge of speaking to the Radius server. And we have a demo that I would like you to see, if I am able to open a browser. This is a kind of recorded demo. If any of you are interested, we have a real demo with a real access point. Well, maybe it's easier. Well, the first thing is it's an all-in-one demo. Well, we are just setting up some minor things. If you can see, this is the radio server starting, and we can see just our configuration. That is the Perl module that we have added, and the most important things about the configuration. We are using PAP and the authentication protocol that I've told you. After that, we are going to start the supplicant. We have developed a wrapper that it is in charge of connecting both the WPA supplicant and the identity selector. We have just selected a self-issued card to be used in our protocol, and that information is put in the WPA supplicant, and the WPA supplicant is going to send that information along with the typical information, in this case is the username and password, to the radio server. We put the password, we introduce the password. Well, the kind of parameters of WPA supplicant. You can see here the information that is going to be sent by the supplicant. It is the user password, the card ID that I commented previously, and we also can see some results of the Radius authentication. Okay. In this point, the authentication with the radio server has been a success, and we have been able to get an information card. The information card has been automatically downloaded, and we are going to be able to, we have been prompted to import the downloaded information card into the identity selector. This is the EduROAM information card that it is backed up by a self-issued card. And we have been able to add the card, and we can retrieve the values, the attributes, using that card. If we see it further, we can see the information that I was referring to previously. And also, we can be some information that if we move over here, well, just here, you can see the URL that is to be sent to the user just to download the card, and some other information, the card ID of the self-issued card, okay, so you can be that is a real, of course, that information that I was commenting previously. Using this downloaded, got info card, we could use it to access any service in the federation. For example, we are trying to do a simple demo. We are trying to access an SP. We are getting redirected to our IDP, and we are going to be required to get an information card. If we choose the self-issued card, it's not the type of card he is requiring. He needs the EduROAM information card, so we finally choose the EduROAM information card, and we are able to access and to get our attributes properly populated. Well, also, we have to collect the accounting about the user and about the connected users and about the status of the user. We have set up a small database where we can see the connected users and the card ID that they are using and the card that he is using at the moment. Once the user disconnects from the network, we would delete that row from the database. Also, and that's all. Oh. If we come back to the presentation, we have some future work. We have been able to make some kind of integration with WPA Supplicant, and we would like to work also with Open Supplicant, but we had some problems with Linux support at the moment. We were thinking about moving to Radiator because free radios it has been really hard working with free radios because, well, a lot of problems that we have suffered, and we need to handling accounting info. Just at the moment, we do not have any access point that do accounting. We are a very poor project, and we also, the only thing that we have is Linksys, access points that do not provide that kind of information. So we would need that information. And some acknowledgements. The first and the most important is to Samuel Muñoz Hidalgo, that has been the developer of most of the work, and the two projects that have been supported us, one of the Spanish Ministry of Education and also to Rediris.
Thank you. We have time for 1-2 questions. Are there any questions for Enrique? There is one, Tomas.
Two questions connected. You said that when the user disconnects from the network, you invalidate the card, yes?
Yeah.
But how do you observe that the user has actually disconnected? Because this is, well, the disconnection happens at the service provider side, whereas the invalidation should happen on the IDP side. And the other thing is, how do you handle very frequent reauthentications that can happen in
Well,
.1x?
that's two key points. The first one is we need to populate that. We have not been able to test it because of the limitation of our hardware, but we needed to populate that account information to the IDP to update that. But even in the case that we do not update that information, we have set up a time lifetime to the cards, so the cards gets age and we can delete it because they are old enough. They have an associated lifetime with them. And related to reauthentication, we have not tested that feature sufficiently, but we think that we are going to be able to deal with our state machine. We have tried to put this on our requirement list, but we have not been able to test it as much as we want.
Hans. And plus after Hans. Hans was first, sorry.
Have you considered issuing long-lived cards so that people can reuse the card when they're on a next network that is not edu-roam enabled?
Well, you have two choices. Use long-life cards, and you can use the card. You have a normal card. I think that's the kind of normal card that we are using. But the thing is that this is really, if you are doing that, you cannot, for example, you cannot carry your card with you. And with this model, you could carry your card with you because you only need to generate a new self-issued card and just get your personal edu-roam information card. And it doesn't matter wherever you go. It doesn't matter the device you are connected from. You only need to generate a new self-issued card, and the card gets automatically imported into your device, into your identity selector. So it's easier. I do not have to. For example, I have an iPhone. There is no support for an identity selector in my iPhone, but we could think of having something like an Android device or something like that had that kind of support. And also, I could have my laptop, and I didn't want to put all my information card in all my devices. I just want to connect to edu-roam and just forget about everything, because every time I connect to edu-roam, I get an information card. So it is easier, and also it's more clearly associated with your edu-roam session.
Okay, thanks.
I just wanted to point out one thing that perhaps was not obvious to everybody, just to be on the safe side. What you showed was lots of debugging information, etc., to demonstrate how the process works. But for the end user, he's just using his supplicant like he always did, and then uses his card selector to select a card. So for the user, nothing really changes, right?
I think I haven't understood the question very well. That you're using that for user, nothing has changed.
What I wanted to say is it's not as complicated as it looks like if you see all the things scrolling over the screen. You just enter your edu-roam credentials, and you have an information card selector where you just select your information card and that's it.
Yeah, yes, that's only to see a live demo, and if you want to, maybe you want to get into more detail, and you have a real case, a real use case. But for a normal user, you will get the same kind of user experience that you get with a normal information card, but also forgetting about password, because you don't need a password with this SIM.
Okay, do we have some more questions? No. If not, then thank you again. And thank you all for being here, and see you tomorrow morning.